Good afternoon, everyone. So we are the group 4. Together with me is Pedrosa Nathan, the cadet Pascual Michael Joel, the cadet Napoles Paul Vincent, and I am the cadet Yaon Rico. So our course outcome: solve problems by great circle sailing in determining difference of latitude, difference of longitude, great circle distance, initial course angle, final course angle, latitude of vertex, d long to vertex, and longitude to vertex. Learning outcome: at the end of the session, the student shall be able to determine courses and distance by great circle sailing. Importance of the topic: the great circle route is the shortest distance between any two places. These circles are beneficial for following the shortest distances between any two places and help in saving time for the navigators. So the problem is determine the great circle distance and initial course from latitude 1, 37 degrees 47.5 minutes north, longitude 1 to 2 degrees to 7.8 minutes west, to latitude 2, 33 degrees 57.1 minutes south, longitude 2, 151 degrees 12.7 minutes east.
So to get the D lat and D long, first is to get the latitude 1, which is the given 37 degrees 47.5 minutes north, and the latitude 2, which is 33 degrees 57.1 minutes south. So note, if same names, subtract. If different names, add. So it is, as we can see, it is different in name. So we must add it. So the answer for the DLAT is 71 degrees 44.6 minutes south. Why south? Because uh from latitude 1, which is north, to latitude 2, which is south. So south. Next is longitude 1, which is the given 122 degrees 27.8 minutes west, and longitude 2, 151 degrees 12.7 minutes east. So different name. So we must add. And the equivalent is 273 degree 14.5 minutes east. Why is? Because it's going to east. Then from note, if DL is greater than 180 degrees, we must subtract it to 360 and reverse the name. So we subtract it because it is greater than 180. And the answer is 86 degrees and 19.5 minutes west because we reverse the name.
So great circle distance. So to find a great circle distance, this is a formula you should follow. Cosine GCD is equals to parenthesis cosine D long times cosine latitude 1 times cosine latitude 2 close parenthesis plus or minus parenthesis sine lat 1 times sine lat 2 parenthesis. So cosine RD long, which is 86 degrees 19.5 minutes west times cosine latitude 1, which is latitude 1, which is 37 degrees 47.5 minutes north times latitude 2, which is 33 degrees and 57.1 minutes south, then minus the sine 37 degrees 47.5 minutes north times 33 degrees rather 57.1 minutes south. So why is it we will subtract from we will subtract the sine sine lat 1 times sine lat 2 because our latitudes have the same name, so we will subtract from slide. Can you show us the next slide, please? So this is our rules. If the latitude names are the same, we will add. And I mean, if the same latitude means add, this if different latitude names is subtract. So go back to the next slide. So great circle distance. So here is a formula to find the great circle distance. Cosine GCD times cosine D long times cosine latitude 1 times cosine latitude 2, then plus or minus parenthesis sine lat 1 times sine lat 2. So our cosine D long, 86 degrees, 19.5 minutes west, times our cosine latitude 1, which is 37 degrees, 37.5 minutes north, times our cosine latitude 2, which is 33 degrees, 57.1 minutes south. Then we will subtract because our latitudes were different names. So sine minus sine 37 degrees, 47.5 north, and sine lat 2, which is 33 degrees, 57.1 minutes south. So our cosine 86 degrees, 19.5 minutes west will become 0.06410 times the cosine latitude 1 will become 0.79024 times 0 times cosine latitude 2, 0 0.0, 0.82951 minus sine lat 1, 0.61279, then let sine latitude 2 become 34224. Then cosine, then we will multiply per parenthesis, it will become 0.0420 minus 0.344224. Then we will have negative 0.30020. Then we will use inverse cosine to find the GDC in degrees, and it will have a product of 107 degrees, 28.2 minutes. Then to find the GCD, we will find it through by nautical miles. So we'll multiply it to 60 because 1 nautical miles is equal to 60 minutes. So to convert it to nautical miles, 107 degrees and 28.2 minutes times 60 will become 6,448.2 nautical miles. So that's will be our GCD. So here's the rule. If same latitude names, we'll add. If different latitude names, we'll subtract. To convert GCD to nautical miles, multiply it to 60.
So for the initial course, we have our formula. Sine initial course angle equals cosine latitude 2 times sine d long divided by sine great circle distance or GCD. So to substitute, we have cosine 33 degrees 57.1 minutes south, which is the latitude 2, and multiply to sine 86 degrees 19.5 minutes west, which is RD long, divided by sine 107 degrees 28.2 minutes, which is RGCD. So note that in substituting the GCD, we have to use the degree form. So next is for the cosine latitude 2, it has the equivalent of 0.82951. And for multiply to our sine d long, which is 0.99794 divided by the sine GCD, which is 0.95387. So since we need to find our initial course, so we have to transpose the formula. So to get that sine -1, we have to click our calculator in shift, then click sine. So it will automatically go to inverse sine, and the result for the formula is 0.86783. So to click that, click our calculator into degrees. So the result is 60 degrees, 12.5 minutes. So to get the direction, we have here the rules. So make latitude 2 negative if crossing the equator. So in naming, prefix must be according to the latitude 1. So our latitude 1 is in north direction. So we have here the prefix, which is north. And next, suffix must be according to our D long. So our D long is in westerly direction. So we have here north 60 degrees 12.5 minutes west. So in order for us to get the initial true course of this, so we have here the diagram. So we have here the four quadrants. So if in northeast direction, we will maintain it or as is. So if in southeast direction, we have to subtract 180. And in southwest direction, we have to add 180. And in northwest direction, we have to subtract 360. Since our initial course angle is north 60 degrees 12.5 minutes west. So in northwest, we need to subtract this 360 degrees to convert to true course. So now our initial course is 299 degrees point 8 299.8 degrees true. So this is what we need to keep in mind. Note, GCD must be in degrees, as I have said earlier. Make latitude 2 negative if crossing the equator. Naming prefix according to latitude 1, suffix according to D long. To get the true course, so we have here the diagram.
So for the final course, the formula of final course is sine final course angle is equal to cos lot 1 times sine d long divided by the sin GCD or the great circle distance. So let's substitute it. For the cos lot 1 is cos 37 degree, 47.5 minute north. And for the sine D long is sine 86 degree, 19.5 minute west. And for the sin GCD or the great circle distance is sin 107 degree, 28.2 minute. So for the answer of cos lot 1 is 0.79024, and for the sine D long 0.99794, and for the sine GCD is 0.95387. So the next is 0.78861 over 8 0.95387. So for the final course angle is we need to inverse the sin. The answer of the 0.78861 and divided by 0.95387 is equal to 0.82675. So as what the rule said is we must be in degree if we find the GCD or the great circle distance. So in equal to is north 55 degree 46 minute west, and then we must subtract to 360 degree to convert to verse. So the final course is equal to 300 304 degree and 14 14 14 minute. Sige na. Usa gina pre?
True, pre.
T.
True.
True. Next three. So the rule of final course, the great circle distance must be in degrees, as what I said. Make latitude 1 negative if crossing the equator. For the naming, the prefix contrary to latitude 2 and the suffix is same as the long.
So that concludes our presentation. Thank you and God bless.